Let's see, children, now what is the concept of parallel lines and the condition for parallel lines, and that of perpendicular lines also when it comes to coordinate geometry. Now, if I were being given two lines, if there are two lines given to us, then how to identify, in coordinate geometry mind you, how to identify that the two lines are parallel? And on the same lines, if there are two lines given to us which are intersecting, how to determine that they are perpendicular? So here we are going to understand how to determine two lines parallel, right? So say for instance, it is given to me that this is one line L1, or say line L, and this is line M. Say this is passing through A, B, this is passing through P, Q. But natural, when I say that line L passes through point A and B, so I will be having the coordinate x1, y1. Likewise, I shall be having a coordinate x2, y2 on the same lines x3, y3 and x4, y4. So given to me that there is line L which is passing through point A and B, whose coordinates are known to you, mind you, it's given to you. Line M which is passing through PQ, whose coordinates are also you are aware of. Now I am being asked, what is line L parallel to line M? Then what is the condition? The condition is, we will always find out the slope of both the lines. We will always find out slope of both the lines. So I'll find out slope of line L. You are aware how to find out slope. What is slope formula? y2 minus y1 upon x2 minus x1. What is slope formula? We have learned this. y2 minus y1 upon x2 minus x1. So I shall find out here y2 minus y1 upon x2 minus x1, since coordinates are being given to me, and let me say my slope is m1. Whatever value I get it, I just say that is m1. On the same lines, I am supposed to find out the slope of this line also. How this will be found out? y4 minus y3 upon x4 minus x3. Right? So can I get the slope of both the lines? I'll say this as m2, this is m1. First line m1, second line m2. I repeat what was given to us and what we have done. Given to us was line L and line M. We were supposed to find out whether the lines are parallel or not. What did we do so? With the help of the coordinates given, we found out the slope of line L, which we have designated as m1. With the help of the coordinates given, we found out the slope of line M and said m2. Children, if m1 is equals to m2, then lines are parallel. If m1 is equals to m2, then lines are parallel. Lines are parallel. So what is the condition for two lines to be parallel? The condition for two lines to be parallel is their slope should be the same. The condition for two lines to be parallel is that the slope should be the same. Let me say exactly converse of it. If the slopes are same, then the lines are parallel. Converse. If the lines are parallel, slopes are same. So let me write down the converse statement also. If the lines are parallel, then their slopes are equal. If the lines are parallel, slopes are equal, right? Now what happens if you are thinking that when I am supposed to use this and when I am supposed to use this? Answer is, if you are being asked to find out the two lines parallel, then I shall always find out their slopes. If the slopes happen to be the same, lines are parallel. So when I am going to say this particular statement, if the lines are parallel, so say for example, there is one line L whose slope is given to me, m1, which is half. There is one line M. Given to me that L is parallel to M. I am being asked to find out what is the slope of M. I shall simply say, since the lines are parallel, slopes are equal. The slope of L is half, that of M is also half. As simple as that. So if the lines are parallel, then their slopes are equal. So slope of this, say this is M2, this was M1, M2 is also half. M2 is also half. Got the condition, children? So once again I will reiterate for the last time. If the lines are parallel, then the slopes are equal. Converse, if the slopes are equal, then the lines are parallel. Right? On the same lines. On the same lines. If you have understood this, this becomes very easy. But the condition is slightly different. The condition is slightly different. Given to me that there are two lines which are intersecting in this way. Say this is line L1 and say this is line L2. This is line L1 and this is line L2. And what I'm being questioned, I'm being asked whether the lines are perpendicular or not. On the same lines as we have studied over here, here also the coordinates are being given to me. Here also the coordinates are being given to me. So what I'm going to find out? I'm going to find out slope of L1, which is M1. I'm going to find out slope of L2, which is M2. I'm going to find out slope of L2, which is M2. Then answer is, if the lines were to be perpendicular, then the product of the slope is -1. If the lines were perpendicular, then the product of the slope is -1. Converse, if the lines are perpendicular, the product of the slope is -1. So, let me say M1 into M2 is -1. So, what is the condition for perpendicular lines? The condition for perpendicular lines is that product of the slope is nothing but -1. So, let me jot down the statement in this way, right? This was first statement here, this was the second one. On the same lines, let me jot down. If M1 into M2 is -1, then lines are perpendicular. If M1 into M2 is -1, then the lines are perpendicular. Converse. If, let me say converse statement. If lines are perpendicular, then I can directly say, then M1 into M2 is -1. So for instance, if I want to check whether the lines are perpendicular or not, say for instance, the value of M1 turned out to be, I'll write down a different marker so that you can understand. Value of M1 turned out to be 3/4. Value of M2 turned out to be -4/3. Now children, what is product of 3/4 into -4/3? Answer is -1. Answer is -1. So I can say lines are perpendicular. Right? On the other hand, where I will be using this? I'll be given one of the slope. I'm being told that the lines are perpendicular. I need to find out the other slope. M1 is given to me. I'm supposed to find out M2. And I'm being told that the lines are perpendicular. Since I'm being told that the lines are perpendicular, if the lines are perpendicular, then the product of the slope is -1. So I shall write down M1, which is known to us, into M2, which we are supposed to find out, is -1. On solving, I'll get M2 as -4/3. On solving, I shall get M2 as -4/3. Are you getting me, children? These are what the conditions for parallel lines and perpendicular lines. So for lines to be parallel, slope has to be same. Converse, if the slopes are same, lines are parallel. If the lines are perpendicular, then the product of the slope is -1. Converse, if the product of the slope is -1, then the lines are perpendicular. Right? Very simple. Just keep this in mind. It is going to be very, very helpful, useful when we solve problems based on parallel lines and perpendicular lines.